really happy to see you in my third presentation video, and today we intend to talk about the possibilities, which means also eventualities in the systems we are investigating. So the topic is, honestly, this is a really hard thing to continue with as a conversation or presentation video. So my purpose for today is just bifurcate the videos until its parts. I mean, I will present the eventualities and their complexity and their importance, I mean, in the parts, the quantum mechanics and their possibilities, the classical mechanics, as you can see from our work, the visible parts, and measurable, observable things, and also the macrocosmos, the big, enormous dimensions. So it will be really interesting thing, I guess, and the reason why I prefer to present this video is I just want to show and also present the importance of possibilities, because they are everything. But in fact, I would like to add, before I start, the possibilities I intend to present you are not the mathematical possibilities. Okay, they are mathematical, but not directly. I mean, these are recondite issues to talk about. In this way, we had better to continue in physics and the physical possibilities, which is also dependent to the mathematics, and the essential parts are coming from math, of course. So before I start, as I said, I will separate the parts, so it will take not long a time to record this video, and it's easy to upload it to the YouTube. And yeah, that will be really nice. So to speak, the first dimension or the place we are intending to present and talk about is the quantum mechanics. What we call and what should we understand from the quantum mechanics, or the ENG name? Honestly, this is a dimension very small. Can you imagine 1 nanometer and very small? I mean, if you continue to go deeply, you will not be able to see the particles and the other behaviors of the other things, because everything in that dimension or in that place is or are invisible, and also they have very high velocities, the accelerations, and if they have mass like electron, the protons, not protons, but yes, they have the momentum. In this way, it will be really hard to continue one thing as the understanding the thing. So before I start, as I said, do not ignore the possibilities in the systems, except some the other physics laws, which is also the gravitation and other parts, that are sometimes we can ignore something, but in this measurement we can't. So for particles and the quantum dimension, the atomic dimension, and deeply, I mean inside of the nucleus, like quarks, bosons, fermions, neutrinos, the other parts, the possibilities are very important, and they are something you cannot ignore easily. I mean, what we intend to do is, or are not unjustifiable things towards your attempts to the experiment. So why are the possibilities are important in quantum mechanics? For example, imagine an electron that orbits around the nucleus. What we can say, honestly, in fact, from the observer that is investigating and soon afterwards inferring the system, he or she or the observer says that, yeah, the electron that orbits around the nucleus has a kinetical energy, because, yeah, it's a velocity and the mass. Of course, we know that the electron has mass, and also we know that the distance between the electron, the particle, honestly, it depends how you measure, because they can also behave like particle and also the wave. So we are using the wave functions to calculate it, you know. Between the electron and the nucleus, they had the potential energy. For classical mechanics and the classical mechanics understanding towards the system, we can calculate and measure the orbit of the electron. But it will be not true that much. I mean, your observation and your measurement, your experiment towards the electron and its orbit would be not certain. This is why the importance of the physics is here occurs towards us. What can be happen? Why is not that what I'm going to observe is not true? The problem is they have the velocity, the speed that is near to, I mean, the speed value of electron or any particle in quantum mechanics is near to light speed, which means that your observation is going to be not certain. I mean, you cannot deduce anything easily because you don't know where it is exactly. Or for example, if you know the electron or any particle about the place and its import as time passes, because we know that these values and the issues are interchangeable as time passes. In this way, it is not easy to determine how they are acting and what is visible. So the physics laws, in fact, they are going to validate the other parts, but it depends on your observer. So we are coming back. For the electron, you cannot understand how it's behaving. When you're trying to understand the system, the electron behaves like a wave, which means that it's an energy. Yes, we know that. And when you don't, I mean, when you do not anything do towards the system, it's act like a particle. We know that there is an electron. There must be an electron outside of the nucleus because of, you know, that the Coulomb force, right? The Coulomb force is important. We cannot ignore. So as you can understand, these things are very confused without the possibilities. So we are using in the modern physics, not the Newtonian physics, the classical mechanics, the possibilities and the modern atomic theory, you know, the atom theory. In this way, this system or this solution is the best and the most suitable thing to understand the nature of the particles, electrons, protons, and the other smaller particles. You know what I'm talking. In this way, it's important. As I said, the possibilities are important because according to the Heisenberg uncertainty theory or the law, we cannot determine where it is, or if we know where it is as an orbital or any place that is or that has a value of possibility in a higher speed or the higher number, we know that it is there, or with speed of its electron, it's there, and we know the value, but we don't know where it is soon afterwards. This is why we are using the possibilities. And according to possibilities, but what kind of possibilities? Of course, the Schrödinger wave functions. They are best way to measure the calculations towards this system because it depends on the energy of the particle, the electron. For example, if you know the energy, the potential energy and the kinetical energy, you can calculate with mass, the Dirac constant and the Planck constant, and continue your calculation because the wave function depends the energy of the particle. So as you can say or imagine or think, we can evaluate, and afterwards we can we can create a solution that is available for time-dependent possibilities for quantum mechanics. So what do you do with possibilities? The possibility would show you where it can be as a possibility and how it will act in the future or at the past. And if you know where it is right now, you can also calculate it as a place, energy level, or the situation of the particle in the future at the past. How is it possible? It is possible with wave function. Wave function is a solution or the way that is giving us an opportunity to calculate these things because they are faster, very fast, not as we used to hear as daily life. I say the light speed. In this way, it is important, right? So we are using the wave functions. It depends on your observation, what you are measuring. And imagine this, what I said and presented was just available for, It was just an example for one particle, electron. Can you imagine? There are many atoms outside of us, environment, everything is in the universe coming from the atoms, the quantum mechanics. So how many possibilities can you imagine? The millions or maybe infinite numbers. So as you can see, if we know the possibilities for quantum mechanics, we can understand the nature of the particle, but just its visible behavior. So for now, let's investigate it at the board. I will going to present the Schrödinger equation.